So section 2 is called Capture, Recapture, and that'll make sense in a bit when we start looking at fish in a lake in our story problem. But to help us out, there is a proportion that strictly deals with percents. Okay, and there's a nice little wording that goes with it that helps you remember like how to set up your proportion. And it goes is over of equals percent over 100. So this guy right here, is over of equals percent over 100. Well, why do you put a percent over 100 anyway? Well, let's think about that. If I have 75%, if I wanted to write that as like a decimal, that's really, if you remember how to write it as a decimal, the decimal's right there, 75.0. So to write it as a decimal, as a number, we would move it 2 places to the left. So it's really 0.75. And so to get that, I would put 75 over 100, right? Because everything's based off 100%. That's like the full percent. Which if I simplify that fraction, that's 3/4, which is really 0.75 as a decimal. Okay, so that's where that thought process, that percent over 100 comes from. To know that we always use 100 over the underneath the percent. So is over of equals percent over 100. All right, and I'll show you what I mean. So it says, what number is 15% of 120? So I'm going to write my percent proportion up here. Is over of equals percent over 100. So I could just fill it out. So let's take a look. What number is? So is goes with what number? I don't know what it is. So I'm going to give it the variable x. So x is the is over of. Well, what's of? Of is 120. So is over of equals percent, which is 15, and the percent is always over 100. There we go. And remember, you can either solve just like we did before, algebraically or with the cross product. I'm kind of a cross product machine, so I like to do that. So 100 times x equals 120 times 15, which is 1800. And to solve for x, I divide by 100. So x would equal 18, just like that. Okay, and there is one quick method. Anytime you're finding a percent of a number, anytime you want to find a percent of a number, the quickest way to do that is to change your percent to a decimal, which we just talked about. Move it 2 to the left. So 15% is really 0.15. And of tells you to multiply. So 0.15 times 120. So if you ever want the percent of a number, all you have to do is change it, the percent to a decimal, and multiply. And I should get the same answer. What about if you're trying to find the percent? Okay, well, there's 2 ways to do this as well. The percent proportion works out just nice, so I'll do that first. So is over of, so is goes with 25. 25 is of 68. So is over of equals percent, and I don't know the percent, so that's an unknown, so I give it x over 100. And same thing, I could do the cross product, or I could simply multiply by 100. So x would equal, well, if I think about this, when I divide these two guys, I'm basically multiplying by 100, which just moves your decimal 2 to the right or adds 2 zeros. So I could type that all into a calculator, 100 times 25 divided by 68. Or the quick way to do this, if you're ever trying to find a percent, just put your is over of. So for example, 25 over 68. And find what that is a decimal. And in this case, it is 0.3676, and it keeps going on. So 0.3676, it goes on and on and on. Well, we're telling you to multiply by 100 to change it to a percent, which really, if you want to change any number to a percent, we just move it 2 decimal places to the right. So it's really 36 point, round to the nearest tenth. So the 6 tells me to round up for the 7. So 36.8. And don't forget your percent sign, right? Let me repeat that. Don't forget your percent sign. Okay, so there's a couple of quick tricks, as you notice on the right side, when you find a percent of a number or you find an actual percent, or you can always use the percent proportion. And lastly, this is when it gets a little bit trickier. This is where I really like to use the percent proportion, is when you don't know the of. So 85 is, of we don't know, so we give it x, is over of equals percent over 100. Remember 2 ways to do this, cross product, or in this case, If you didn't want to do the cross product, remember you would flip it to get that variable on top, and then 100 over 102. But since I'm just a cross product machine, I'm going to do that as well here. So 102 times x, 102x equals 85 times 100. So really to solve for x, we're going to divide by 102. So x would equal 83.3 repeating. And we don't want to write it as that. Let's get used to writing it as like a fraction if it's a nice fraction. So x would equal 83. Well, remember our rule. If it's one decimal repeating, 0.3 repeating, I can put that over 9, which is actually 1/3. So 83 and 1/3. We want to try to be as exact as we can now that we're in algebra. All right, so now let's look at our recapture. So it says, how would you determine the population of fish in a lake? Well, you can't count them, and you can't catch every single fish. So how could you do that? Well, you could do it with your proportional thinking. So think about a lake, okay, and just think about all the fishies in the lake, all over the place. There's fish all over. Okay, just like that. Well, what if I caught 50 fish and put tags on them? And we tagged 50 fish. Okay, so we captured them, and then we tagged 50 of the fish, and then we threw them back in the lake. So those 50 tagged fish are now in the lake. And then we go ahead and we recapture some fish. And we realize out of let's just pretend we snagged 40 total fish. Out of the 40 total fish, 8 of them were tagged. So 32 were not tagged. Could I solve for how many fish we could estimate are in the lake? Sure, we could set up a proportion. So think about this. During the capture, 50 were tagged, right? Out of how many total are in the lake? Well, we don't know. So we put an X there. So 50 out of X. So 50, remember that represents the tag. Sometimes I like writing stuff on the side so I know what matches up. And X represents the total fish, right? Well, I can set that equal to my new ratio I just found. 8 out of 40 were tagged, right? So where does that go? Does the 8 go on top or bottom? Well, top has the tag, so I better put 8 on top. Remember, they have to match up over 40 total fish, right, on the recapture. So now I could solve for an estimate of how many fish were in that lake. So I like the cross product. So 8 times x, 8x equals 50 times 40. So that is 2,000, and we divide by 8. So we could estimate that there are a total of 250 fish in that lake, right? It's probably not exact, but it's got to be pretty close based off my proportional thinking. So now let's use that to help us solve a few different problems. So in a capture-recapture, 300 fish were tagged initially, right? From the recapture results, the game warden estimates that the lake contains 2,500 fish. What percent of the fish were tagged? So this one's a little bit different, isn't it? So there's 300 tagged, and they estimated that there's 2,500 fish. Well, I could write a ratio here. There's 300 tagged in the lake total, right? And we're estimating that there's a total of 2,500 fish. Well, how do we find percent again? Don't we have a percent proportion? We can say that equals percent over 100. Oh, there we go. So let's solve for x in this case. So a lot of ways to do this. I could take my cross product right away, or what do we talk about? Anytime you have a ratio, you can simplify, right? Can I simplify this fraction over here? Sure. Anytime they end in zeros, we can cancel zeros, like divide by 10, divide by 100 in each case here. So that's really 3 over 25 equals x over 100. And now I could just look, well, how did 25 get to 100? Times 4. So what do I do here? Times 4. So really, x equals 12. And what's our label? 12%. Remember, I always go back and reread. What percent of fish? So I could have taken the cross product, right? That 2,500 times x, and then 100 times 300, 3, and then 4 zeros. and solved it that way, that'd have been fine. But remember, you can always simplify ratios to make things a little bit easier. So we just kind of use what we learned in that last slide to help us solve for a percent now. Let's do one more. In a lake with 350 tagged fish, recapture results show that 11% of fish were tagged. About how many fish are in the lake? Okay, so we know a percent, right? So I could set that part up on my percent proportion. 11 over 100, percent over 100. So just think about this. Remember when we did is over of? Well, if I thought about parts and wholes, how would those apply to these? Where would the part go? Yeah, the part would go with the is, and the whole would go with the of. So let's just think. It said 350 350 fish were tagged. Is that the part or the whole? Yeah, the tagged is the part. So that would go here, where X is the total. Remember, that's the whole? Total fish in the lake. And so now we got a cross product to solve, a proportion to solve. So 11 times X, 11X equals 350 times 100. So 350, add 2 zeros, and divide by 11 to solve for the total amount of fish we're estimating are in the lake. We get about 3,181. It says 0.818, and it keeps repeating like that. Well, we don't want to round. We don't want a decimal amount of fish, so we're going to say about 3,182 fish. So technically you should say about, right? Because it's not exact. So there we go. Just using that percent proportion or proportional thinking to apply it to some real world situations.